Hey, Mr. Danner Miller. My name is William Washburn. I'm part of your Engineering 1315-DO1 Intro to Engineering class, and this is going to be my double pulley system project final presentation for the due date tomorrow. So let's get started. So, intro for me. So, I'm going to be a mechanical engineering major. That's what I'm trying to do right now. And I have close to 2 years of what I'd call engineering experience from my high school, where me and a group of students entered into a challenge called the Solar Car Challenge. It's where we kind of just build a car ourselves, and I won't get too much into it, but it required some real engineering experience like CAD design, designing and planning, and time management and stuff like that. So here's two pictures of me in the little red squares. Those are both me in those pictures. So for this project, I had to build a double pulley system as the requirement for the off-campus class. And this system is to assist in lifting 3 objects, and I'm diagramming the system and explaining how it works. I'm explaining how it creates a mechanical advantage for the lifter. I'm going, you weigh 3 objects, and then you lift 3 objects with the system, and then, contrast the difference in force used with the system as compared to just lifting it normally. So for my first design and improvements, at the very start, my initial ideas revolved like an upside down U-shaped design with like a wooden frame and then metal brackets. And I was going to decide between either a 2 fixed pulley or 1 fixed and 1 moving pulley system. And then so this was kind of just based around me looking at what I had and thinking about what would be easiest for me to make and to, describe and demonstrate and present the best. So for my prototype, I went with the 1 fixed and 1 moving pulley system because that looked way better than the other one had, and it looked like it'd be easier to talk about and easier to describe. I went with a Z-shaped design hanging off the edge of a table. That way I'd have the most room to, let the weight, just like the way the system would hold together, just off the table it looked correct. So instead of metal brackets, I started off with wooden brackets for my prototype because metal brackets felt like it'd be kind of a waste. It wasn't really under too much strain. It just needed some structural support on the side so it wouldn't lean over too far. Now, this prototype did show the correct correlation between force needed and the weight of an object. With 2 pulleys, the force would be divided by half and the distance would be doubled. And that did, in my earlier video last week, it did show those qualities in the testing and review of that. And I think the design looked pretty alright, but it could be cleaned up and look better for the final version. I didn't need to change any core principles or ideas because those were followed correctly. And its strength, that it had accurate measurements, it did what I wanted it to do, and the weakness was kind of a basic, plain design that I wanted to change some to look a little bit better for my final iteration. So design changes for the final iteration, the final product. I didn't change the way the pulleys worked or the paracord. Those worked just fine. I didn't want to alter those measurements very much. And I made the wooden brackets a little larger to just kind of, look a little bit better and fit the design better. I replaced the handles on the weights from braided rope to galvanized cable because I thought they looked a little sleeker and a little bit cleaner. And that weighted rope would be a little heavier than what I wanted. And then I used like a matte gray primer paint for aesthetic effect. I could have used another coat, but I felt this just looked good on its own. And that's really all the changes I made for the final iteration of the project. So for the final product, we had to, the diagram I created for it, I guess I'll start with the dimensions. It lengthwise 19 1/4 inches by widthwise 9 3/16 inch by height 46 5/8 inches, which was inside the 4x4x4 dimension requirements. For the objects I lifted, I went with 2.5, 5, and 10-pound circular weights that I wrapped a wire around and lifted with a metal hook. 2 pulleys in this system, so force would be divided by half. Expected lifted force, 1/2 force required, double the distance needed to pull to lift the object the same distance. And here you see the both diagrams. One just lifting the weight directly, where it shows how there's 2.5 pounds of force being pulled by the weight gravity-wise, and 1 object lifting it up. So it's just direct to the scale, 2.5 pounds lifting force. Now with the double pulley system, the weight being pulled down by gravity is divided in 2 by the first rope attached to the first pulley in the bottom, and the second pulley wrapped around being pulled by the pulley. and the hook itself. So the weight is divided halfways, 1 1 1/4 pounds each. So the force needed to lift the object is only 1 1/4 pounds. So yeah, half the force of the weight. Now for my testing I did with this one, I did the initial scale reading of free weights like shown earlier, where I just pull the scale and I lift it up, each one 2.5, 5 pounds, and 10 pounds. And then I did 3 tests on the actual pulley system, where I took the scale and pulled the pulley system with it, and got about halfway down, or about the same height I would with the free weights, and then averaged those out, and that gave me my final result. And then, so an important note in this was friction was a big problem I had early on with my prototypes and stuff like that. If there was too much friction in the system, the weights would be wrong, the measurements wouldn't be correct, it'd be too heavy. So I added lubrication and like thinner, more smooth materials like the black paracord and galvanized wire, because that was a little bit lighter, it worked a little bit easier as opposed to what I was using. All right, test 1 with 2.5 pound weight on final product pulley system. We should read about 1 1/4 pounds of force, since the weight is 2.5 pounds. So let's see. Smooth movement. Let's see what we're running. Looking at about 1.5, 1 1/4 right now. Okay. Test 2 with 2.5 pound weight on final pulley. Smooth movement. Looking at about 1 1/4. That's about what we want. Third test with 2.5 pounds of weight on final pulley. We're looking about 1 1/4. That's about right. Test 1 with 5 pounds of weight on final pulley. Smooth movement. Not getting stuck. Let's see what we're reading. Hold on. About 2.5. Between 2.5 and 2 3/4. Second 5 pound weight test on final pulley. We're looking at about 2.5 pounds. It's about right. Yep, 2.5. Third test on 5 pound weight. Still smooth. Squeaking a little bit. It's all right. 2.5, 2 1/4. Yeah, it's about right. First test with 10 pounds of weight on final pulley. Smooth movement, not getting stuck. Let's see what we're reading. About halfway down. About 4.5, 4 3/4 right now. Yeah, close to 5, yeah. Second test for final pulley system. Still smooth, still even. Let's see what we're showing resting. If it would focus. About 5 pounds, close to. Yep, 5 1/4. And then third test, 10 pounds of weight on double pulley system, final iteration. Still smooth. About halfway down, resting weight. 5 pounds, around 5 pounds, close to. Got about a 1 pound difference. When you move it some, 5 pounds resting. Okay, so materials I used for the frame, I used oak wood for the scale. I had a Rapala fishing scale, which is something I had laying around. I used 2 feet of 1.6 millimeter galvanized cable. I used 3 Everbuilt 1 1/16 cable clamps, which fit the 1.6 millimeter cable. For the paint, I used Rust-Oleum flat grade primer. and I used, for my pulleys, I had two UEETEK 25 millimeter single pulley blocks. They're both the same. It's just one I screwed into the wood itself, and one I had hanging freely. For screws, I used yellow zinc flat interior wood screws. Those I already had also. I used 72 inches of black paracord. And then the weights were Series 8 Fitness 2.5 pound weight, and the other two were Gold's Gym 5 and 10 pound weights, respectively. So, the biggest hurdle that I think that I had in this system was the problem with trying to remove friction in it to begin with. So at the start, I was using heavy braided, just hemp rope or whatever kind of material it was. It wasn't very good, and it was creating a whole lot of friction, and it was really making my results way worse than they should have been. So once I removed that, and once I started lubricating the actual pulleys themselves, so they rolled smoothly and didn't, grind or hit anything else, it started to work a whole lot better. And that was kind of, the biggest problem I had, and I'm glad I was able to get around that. And so a couple of lessons learned during the course of this project was working solo takes a lot longer than I thought it would. It takes a lot more responsibility. I need to work on my planning some, maybe get that done a little bit faster. Maybe I should complete my prototype and my early stuff a little quicker and not put it off so long. But in general, I enjoyed this project, but I did not like doing it very much solo. It'd be cool with a team, but that's the way it happened. And then that the way I present the information is just as important, if not more important, than how well I put together the actual product. And yeah, so that's about it. Thank you very much.